The only thing that we need to do is maybe practice or go back over that C1 V1 equals C2 V2 equation and talk about how to make an agarose gel and actually make it, and then it can sit till next week. So I think overall today's pretty straightforward. So, have any of you guys made agarose gels before?
Years
Nope.
ago.
Years ago?
And
Anybody recently making some agarose gels? No?
I made, but those are like the pre-made ones we just mix, and then some of them is like we just microwave. So
Right, okay.
yeah, so they were like ready to go.
Got it. So, if you do any of this gel electrophoresis stuff from Megan, she'll send you the agarose powder and things. But if I'm being honest, some of this stuff is the stuff that freaked me out the most when I first started teaching biotech. There's all these numbers and all these letters and X's, and like it just kind of, it made me nervous thinking that about messing it up. You know what I mean? So, if you have questions or need anything, for sure let me know. Um, because it used to stress me out a little bit because I was more of like an ecology biology person, not really some of the molecular stuff. So, um, do you guys feel comfortable with the C1 V1 equals C2 V2 equation that we worked with last year or
Yes.
the other week? Is there anybody that wants to go over a practice problem? There's a few practice problems in your notebook. And it, like this sheet right here talks about making 200 milliliters of 1-XTAE. And then the one below talks about getting a 1% agarose gel. Are you guys good with that, or you just want to go in and make it?
Just make it.
All right, let's go. Okay.
Diving right in.
If you would like to practice those problems and ask questions next week, that would be fine. So in your package, you should have received a baggie that had Skittles, some dyes.
Oh, thanks for the Halloween candy. Appreciate it.
Yeah. Um, a little vial that says 0.7 grams of agarose, a conical tube that says 50x TAE buffer, and a styrofoam thing. Mine really sucks. And it
This
looks
looks
like pumpkin teeth.
explosive.
It looks like pumpkin.
It looks like it could be explosive. I don't know about this, Doc.
It's I don't know. And then you guys should have a soap container and then a beaker and graduated cylinder. I think that's all we need today. We won't use the Skittles or any of the clips, the wires until next week. So all we need to do today is prepare this box. Okay?
Got it.
So I worked out some math today.
Good.
Trying to figure out like what was the easiest, and I don't know what you guys will think when it's all said and done, but Megan gave us 0.7 grams of agarose. Okay. Fun fact about agarose is it's actually a polysaccharide from a red algae. So that's kind of a fun fact there. But so for a 1% gel, so like an agarose gel, I don't know, and if you already know it, just let me know and I'll stop. But like an agarose gel, when you make it, it ends up being this crazy like matrix that DNA and stuff has to migrate through. So we're making a 1% gel, and 1% gel is like a typical run-of-the-mill gel. If you pre-order stuff, it might come and be like a 0.8% gel, but the higher the percent, like the thicker the matrix. Does that make sense? Okay, so 1%, pretty standard run-of-the-mill. So if we want a 1% gel, and Megan gave us 0.7 grams of agarose, we need what amount, what volume? What volume? I'm gonna ask you guys. Anybody?
All right, we have points, we need 1%, we got 0.7
Grams.
M1 V1. So
I'm sorry, what were those numbers again? I missed it.
So Megan gave us 0.7 grams. And we want to make a 1% gel. So the easiest way that I know of is just to dissolve
5 by 70.
that 0.7 grams in 70 milliliters of solution.
Right.
Okay.
Got it.
So now we have to make the solution. And for an agarose for gel electrophoresis, the solution needs to be TAE and water. Okay. So if you guys remember our C1 V1, we are using a 50x stock solution. So that's our initial concentration. I'm trying to get that so it's easier to read.
Alfreda, can you mute your mic? I'm sorry. Can you mute your mic? It keeps coming off and I can't see what she's doing because your mic's on. I'm sorry, Alfreda. Nothing personal, I promise.
No problem. I didn't know it was on. Thank
No, you're good. You're good. Sorry
So
about that.
that's okay. So 50x TAE is our C1. That's our initial concentration. We want to solve for V1 because we're going to dilute this down, this 50x to a 1x. And we want to make 70 milliliters of it. Okay. Bye, Sergi. Oh, you're not leaving yet? Okay. So if we do this calculation and we divide 70 by 50, we should come up with 1.4 milliliters. Is everybody on board with that? Okay. So then in our graduated cylinder, I gotta move my sheet, wrong way. In our graduated cylinder, this is so weird. Everything, okay. We're gonna take our 1.4 milliliters of TAE and we're gonna add 68.6 milliliters of water. And that's gonna give us 70 milliliters total. Are we okay with the math? We're mathing. I struggle mathing at 5:15 in the evening.
See, I'm a little confused about, I understand the ending part.
Yeah.
I'm a little confused how it went from the first sticky note to the second one.
Okay, so
the first one we're trying to figure out, we're trying to get to 1% of our agarose solution, right? And
yeah,
we
so
do that we have to have 70 milliliters and then getting from there to the next part.
Okay, so I'm glad you asked. This is going to be the end product. So this is what we want to make. We want to have our 0.7 grams dissolved in the 70 milliliters, but now we need to make the 70 milliliters. Does that answer your question or no?
And it's 70 milliliters of not just diluted water, but of the other stuff too.
Of the diluted 50x
Right.
TAE.
That makes sense.
Okay.
Yeah.
So
Thank
if you
you.
guys want to grab your graduated cylinder, she gave you 100 milliliter ones, right? Okay. So like, it's
I did not receive a 100. Let me go check. I don't think I received it.
okay. So it's not going to be a perfect world, but if you look at your 50X, there is volume measurements on that. So if you do roughly pour 1.5 milliliters.
We got a big one and a small one. We have a 10 milliliter and a 100.
Oh, okay. Yay
I'm
then.
just legally blind. Don't worry about it.
Okay, so you do have a small one.
Yeah.
So you can either, kind of like your grandma's cooking, maybe like eyeball it, but it's roughly 1.4 milliliters. So you can put your graduated cylinder, pour the TAE in it. So you guys have the small graduated cylinder, and then you can pour 1.4 milliliters of 50X TAE into your graduated cylinder. Okay. Once you have your 1.4 milliliters in your small graduated cylinder, why don't you go ahead and pour that into your 100 milliliter graduated cylinder? And we don't need the agarose powder yet.
I have a little over 1.4. Is that a problem?
No, is that your powder?
Oh, am I looking at the wrong thing?
Or are you looking at this?
I'm sorry. I missed the first part because I was over getting
No,
my
that's okay.
cylinders. Oh, I'm looking at this thing. I got it.
Yes.
I got
Okay.
it.
So 1.4 of this
Okay.
in the small graduated cylinder. And then you can take your 1.4 of the 50X and pour it in the big graduated cylinder. And then anybody, what's the next step?
Fill it with water.
Fill it with water up to
I don't know. My box is covering 68, so 70.
70. Perfect. So does everybody now have in their large graduated cylinder
Okay.
1.4 milliliters of TAE and up to 70 milliliters of water?
Yes, ma'am.
Awesome.
Yes.
Okay.
Awesome.
So I'm sorry. I'm a little behind. It's been a day. I'm sorry,
Yeah.
guys. It's been a day. So I got the 1.4 in the small
Okay.
graduated cylinder. So now I got to put 1.4 in the large one.
No, you need to pour the small one into the large one.
Got it.
Okay.
And then fill it up to where it's 70 with the
Up to
diluted
70 with water.
water. Okay. I am sorry, everybody.
No.
I am super embarrassed.
Yesterday I was about to leave and I realized that the chiller on the trout tank was leaking. But like, what do? So we made a foil ramp so that the water leaked off and dripped into a bucket. And I got to figure out how to fix the leak. But that was our temporary solution. So I get it. Okay. Everybody for the ready for the next step.
Yes.
Okay. So now you're going to want to take your 70 milliliters, which is now 1X TAE. It's diluted from 50X down to 1X. And you are going to want to pour that into one of your beakers. So pour that in your beaker. Okay.
Got it.
Then grab your 0.7 grams of agarose powder and empty that in your beaker. And you can kind of swirl it to mix it. But guys, here's the most dangerous thing. Okay?
Danger.
Danger. Danger, lab safety. So, you're going to need to heat this in the microwave, and you're going to need to heat it until it's kind of boiling.
Oh,
But
it's plastic.
but
So this is why we
agar,
use plastic and not glass, I'm assuming.
these work in the microwave. Obviously they wouldn't work on a hot plate, but so you need to heat this until that, like right now, if you look at your solution, doesn't it look kind of like cloudy and gritty and like,
Yeah, it's settling.
so you're going to need to heat it until it's thoroughly mixed and it's clear, which is kind of hard to tell if it's clear in like an opaque container. But you're going to want to make sure all of the powder, the agarose powder, is dissolved. And it could take, 45 seconds to a minute and a half in the microwave. But the thing about it is you're going to want to do that microwave in small bursts of microwaving because it'll flash boil. Like I did it at home in our own stinking microwave because I got sidetracked with our daughter. It'll just go. So you need to make sure if you have your students make these, that they have their goggles on, have their aprons on, they're not sitting at a lab station. And I was okay because the edges are big on this, but like if you have some hot gloves that they can hold it. But they need to make it and you need to microwave it until it's clear and all of the powder's dissolved. But I always make a huge deal out of being safe with it because it will start to boil quick. Okay. So if you guys want to take a minute, go to a microwave.
I got a rundown for the microwave. We don't have microwave over here.
Okay.
Just give me a couple of minutes. I'll be back.
Okay. Okay.
Yeah, I gotta go to the other side of the school.
Oh no.
So,
Hey, you can borrow my microwave if you want.
okay, I'll be right there.
Okay. So you guys microwave it till it's clear and then we'll meet back. Crystal, do you have your thing cut? Oh, yours looks good. Okay. All right.
I'm sorry.
Where's it echoing? Yeah, you can go ahead and pour that in. And then what you're gonna want to do once you pour it is put your like kind of balance that so that it's down all the way and the tips are submerged. Is it standing up straight in there? You got it to stand up straight. Okay. Sometimes I've had to like put a piece of tape to hold it.
Tricia, can you
Yes.
hear me? Julie Scott had a technical issue and I think she was kicked out. Can you accept if she's trying to join in?
I think she's gonna have to do that with Megan. I don't have the rights to any of it.
Got it. Thank you.
You're welcome. Oh, so some of you guys are coming back. So you should have your, pot clear, everything dissolved, agarose, right? And what you need to do is pour it in where is it? Oh, that part's frozen. My little camera's frozen. You need to pour it in the soap container thing. And 70 milliliters should end up raising it a little over halfway. So you can pour your liquid.
I should definitely not do that with the batteries in it, I assume.
No.
Definitely not.
Yeah. Empty soap case.
And
And then once you have it poured, then you're going to want to put your like modified comb that you've made in.
not
So
do that.
that's what's going to make the wells. So I don't know if you can see on mine.
Is
those
this modified enough?
That looks fantastic. Mine looks like,
Okay. And we put that at the 3 centimeter?
so really I just put mine, I put mine like almost like an inch. 3 centimeters is good. So mine is right here. I don't know if you guys can see that. My camera's not working
Yeah.
now.
Yeah, it's working for us.
Okay. So that's how I have that. And mine's already solidified. I was making mine 4th period, so it was done. But once you get your comb in there, I'm gonna just jam it back in because mine is like crap. And
The comb should not touch the bottom, or it should.
No, it should not. It
Okay.
shouldn't touch the bottom. So it should be, can you guys kind of see how deep mine is?
Yeah.
Okay. So that's what it should look like. And if you are having trouble like keeping it propped up, well, it's still really liquid, you can like put a piece of tape to hold it in place or something, but that's what it should look like. That's about how far mine goes down.
Okay.
Okay. And it took a little bit for this to solidify for me. So really all that you guys are doing now is waiting for it to solidify. Then you can take, once it solidifies, then you can take your comb out. And then you can just cap it. And it'll be good till next week.
So I'm sorry. I'm being completely honest. I did not make the comb yet.
Oh, okay.
I'm looking at these instructions. Do I just need to print it, like cut it as like the picture? Does it have to be exact or?
No, it doesn't have to be exact. So
I'm not
mine is jacked up because like I cut mine kind of at an angle, but you just want them probably like that's probably the best one. So you just want to have like spaces between each of those little combs.
Could you repeat it again, please? I'm sorry, I'm late.
No, that's okay. Sunitha, do you have your comb already made? No, okay. So first thing that you need to do probably, because your gel will take a while, is you guys need to be able to cut this.
Oh, I need to go ahead and put this in the thing, I guess.
okay? But here's the beauty. If you don't have your comb made and your agarose solidifies before you get your comb made and put in, all you need to do is take this out, like just take it out and put it back and re-microwave it. So for those of you guys that do not have this comb pre-made, like it took me a minute to make this crappy thing. So if you don't have it pre-made and your gel solidifies before you get the comb made and put in, just re-microwave your agarose and then re-pour it. Does that make sense or no?
Yep.
And the
Haley?
comb has to be in it when you do it, right?
The comb has to be in it because these little slits,
Okay.
the comb pieces, like the teeth, that's gonna leave an indentation where we're gonna put the samples next week to run gel electrophoresis. Does that kind of make sense or no? Okay.
Yeah, it makes sense. I have no idea if I'm not muted. Okay. Yeah, it makes sense. I'm sorry for not having it ready.
No, it's okay. You know, in the past, Megan has sent like 3D printed ones. So today when I was looking at this, I was like, oh, crap. I'm gonna have to make that crappy with my little teeth. Feel like it's good
I
for
guess.
Halloween or something.
Like how many wells are we making?
6 to 8. 6 to 8 is fine. So Crystal, you have the two of you have your gel with the comb in and it is solidifying. Okay. And then
Same.
same.
Yeah.
Okay, same for Julie. Same for Laura. Shamika.
Oh yeah, I'm working on my comb.
Okay. So Haley, Shamika, and Sunitha have not made their combs. Has everyone else made their comb?
Yep. Yes.
Okay. Yeah, that's the it's kind of the beauty of the aggro stuff is you can just like I did not like mine, so I'm just gonna remelt it and recut my teeth. And then it'll be fine.
So that's basically what these chemical companies are doing. Like they have pre-made all these, concentrations already, and then they put them in the like bottles and sell them. And
Yeah.
here is that, hey, this is really easy. Just put it in the microwave.
Yeah, and
Boom, this is ready.
you can
Yep.
order a big bottle of like the agarose powder, and you can order a big bottle of 50x TAE, and it will last you for a long time, as opposed to paying somebody. So I actually had some kids, the base exam that Megan was talking about, the biotech credentialing exam. So the kids that pass that exam are able to kind of have an unpaid internship, and they make all this stuff. So our science teachers say, hey, I need this many petri dishes or these chemicals or this many gels. Oh, that looks great.
I'm done.
Awesome. Awesome. You might need
Mine
to
is
put
very crooked.
you might need to put bigger spaces
Okay.
in yours, Haley. Like between the
Yeah, like these thingy little flaps. Yeah, I got it.
yeah.
Oh, I see. Like whole pieces. Okay.
And then Sunitha, can you hold yours up again real quick? Is your stuff touching the bottom?
A little bit if I'm closing the lid. If I'm not closing the lid, it is moving up and down.
Are you running yours long way or the short way?
The short way.
Okay, I just couldn't tell because if you're if those are touching the bottom, then next week when you put your sample in those spaces, it's the colors are gonna run along the bottom of the
No,
gel.
I pulled it up now. I pulled it up a little
Okay,
bit.
okay,
Yeah, it's still
okay,
semi-solid for me.
good.
Yeah.
Tricia, I gotta run to the door to open it for my son. So I'll be right back.
Okay,
But mine, I'm solidifying.
okay. Yeah, so I mean, it's really, once you do it, it's not that hard. And if you can train a student to make some for you, and then he can come back or she can come back the next year and help you, or you can train somebody else, it would save time in class, you know? But if you want them to have the experience of making it, do it. Otherwise, if you're just running the gel to show them like DNA is negative or positive and negative molecule stuff, then it might save time depending on your class to have some of them pre-made.
All right, so y'all about to see why I did not teach elementary school. It's not great. I'm gonna be real. It's not pretty. Is that better though? Is the gaps big?
I think that's great. I think it's perfect.
Nah, that is far cry from perfect. The kids could probably do it better, even though they've never done it before. So, so I just stick this in the gel, like I just.
Yep. So your liquid should be in your container, and then you'll just like prop those flaps on the edge.
And it should just barely be sticking in there, not all the way to the bottom.
Yeah. So you
Got
can
it. Got it. Okay, I'll go ahead and see if I can get it to work anyway.
But do you guys have any questions about anything we've done today or anything we've done so far?
So after we make the gels, are we storing them in the fridge?
Yes. So once your gel is solidified, you can take your comb out, the green comb. And if you want to put a little water, just a little water on top, and then you can put it in the fridge. And that should do it.
Does the top need to be closed when the thing is sitting in there?
Yeah, because
Oh, okay.
I would put a little water on top and then I would close it and then put it in the fridge. Because if you leave it out and open, the water that we added is going to dehydrate out. And so it'll like shrink and shrivel up.
So put it in like this, right? Did I do that right?
Are you long way? So
Oh,
go
it
short
needs to be
way.
short ways?
Yeah.
Okay.
Go
Oh,
short
well,
way.
mine is too long. It won't, I might have to cut the sides a little.
Okay.
I don't think it'll, at least the lid won't close when it's, okay.
And really, it's not the end of the world because
Let's
we
see.
can just put the paper clips on the different sides for you. So you decide.
I'm sorry, can I see yours one more time?
Yeah,
I'm visual, I have to see it.
Okay. So here's the short way. And there.
Ooh. How does yours?
Can you
Did
see
you
that?
cut off any extra on yours?
Let me see yours a
Like-
little closer.
Like mine is 90 millimeter, or mine is 9 centimeters, which is 90
So
millimeters.
I have big fans off the side.
Oh, so it doesn't fit.
It doesn't fit perfect.
The lid has to be all the way open. Okay.
And the lid needs to be open until it solidifies.
Okay.
But
Got it.
once solid, you can take out the comb and put a little water and shut the lid and save it for next week.
It's already solidifying a little bit anyway.
Yeah, it's
Not
gonna
bad.
take a little while. I should have timed how long mine took to solidify.
All right. Anyway, I'm sorry, everybody. I don't mean to be that person.
No, it's great to ask questions.
So are we just waiting for it to solidify?
Yeah, so if you don't have any questions, I mean, you can have a good night.
Solidify water fridge. Got it.
Solidify, pull the comb out, a little water, fridge, shut the lid.
So once it's solidified, so can I leave this and come back in the morning and pull it out? Or do I have to wait?
No, I think it's thick enough that you could leave it till tomorrow morning.
Yeah. It's kind of like Jello right now.
Yeah, I would. Yeah, if you want to leave it, it's not. So sometimes we have gels like this, but if you leave them for a day or two and they're not in a baggie or something, they shrivel. So I think it's going to be fine till tomorrow morning. So if you guys have questions, I'd be happy to answer them. If you're good, it was a light evening for us.
So mine is still watery because all the time when I make gels, it becomes solidified real quick. But this is a little watery still. Am I doing good?
Yeah, mine took I mean I would say maybe like 30 minutes to solidify.
Mine's still watery too, though.
Yeah, so mine
Okay.
was watery for a long time. So you should be able to come back in the morning and it be solid.
Tricia,
Yes.
correct me if I'm wrong. I'm just trying to think about the next steps. So next week we're going to get this electronics working so we can separate those whatever dyes or kind of false DNA
Mm-hmm.
stuff.
Exactly.
So we're just gonna use them. Like
Yes.
this modified gel electrophoresis setup that we're trying to really make work.
Yes.
Mhm. Okay.
And we have some labs and I don't know if I've said it or not, but I tried making a lab for our students to go help middle school kids where we did different food colorings, but they represented proteins in different organisms and so of birds. And then the kids made a cladogram based on the colors present. And then there's another lab that we've made where it's using food coloring, it's using dyes, but it's describing like environmental DNA and using environmental DNA to assess a watershed in Northwest Georgia. So like even though it's food coloring and not real DNA and stuff like that, there's still a lot that you can do with the dyes. Like I had my kids, let me show you this picture. This was from today because my kids are doing gel electrophoresis today. And it's, I don't know if you guys can see that.
Yep. Because
So they,
yeah, because my issue was like every time that we do have yeah, that looks good.
yeah,
We do have biotech unit. I end up just demonstrating this to my kids because I only have like one machine, you know. Well, I do have three wells but then there's only one power source and it's very limited. I don't have, you know, the at least six stations, and I don't have a complete set of materials. So in this way, what we're doing now, so I can actually make every group experience creating this or doing this, because
right.
I never had them like do each. I just end up like demonstrating it instead of having them do it.
And
So
Megan will send you, if you have like one of these gel boxes, I think the batteries will last for through a few classes.
Mm-hmm.
So you can
Because,
use the same stuff
right.
all day,
Mm-hmm.
you
Because
know.
we use this in bio, I mean bio one, AP bio, and forensics too.
Mhm. Yeah. And she'll send you the number of pipettes that you need to borrow and stuff like that. So she'd get you everything you needed for to run it for a class. And what school are you at again? What county?
Bibb County, Rowan High School.
Okay. How's everybody else doing? Is your stuff solidifying? Do we feel good about where we're ending?
Yeah, mine's getting hard.
Okay.
Now
So
it's not jelly.
yeah, so I can stay on. If
How
you
do I
guys,
know when it's done?
it will look opaque.
Oh, no, we're not opaque yet, but we're solid.
Okay. So I
I
would
mean,
wait.
we're jiggly. You know, if I
Okay.
pull the green thing out, it's still coming with me.
So do you see how mine looks? Like you can't see through it, but
Yeah.
that's what it should look like. And I
And
mean,
that's when I pull it out.
you don't need to pull. Oh, are you talking about this?
Yeah.
Yeah. Yes.
Okay. All right. I'm good.
Yeah. I mean, and the kids, when they're done with it, they love breaking this stuff. Love it.
So I don't know, you may have already said it. What's the point of the comb?
So give me one
Just
second.
making little molds in it, right? Just for to
Right.
put something in. Okay, that makes sense.
Or you can get it, I mean.
So this is the setup that we have. So you can see like this. So we have this is our comb. And when you pull it out, when you guys end up pulling yours out, can you see the holes?
Yes. Oh yeah, that's cool.
That's what you're gonna load the DNA samples or the Skittle, the dyes. That's what you'll load those into.
Mine did not make holes very well.
So Tricia,
Yes.
when we're putting the comb in, does it need to be in the middle like what you saw, or does it need to be at the end?
So you're gonna want to put it near one of the ends.
That's okay. That's what I had.
Yeah, yeah. And there's a really cheap, like for chemistry or something, there's a really, I mean, I say cheap, I don't know how cheap it is, but it's called like a process to dye for. And they give you different dyes pre-made that will last the rest of your career, like the vials. And some of them go positive and some of them go negative. And you can look up those, like kind of like what we did last week or the other week with the chemical structures. You can look those up and talk about why did this one migrate towards the positive or the negative. So it's called a process to dye for. I think it's Flynn, but and that just gives them like gel experience.
Okay, I'm solidifying and good. So I'm gonna sign off and feed my kids.
Bye, Laura. Have a great night.
See you next week.
Bye.
Me too. Thank you so much,
You're
Tricia.
you're very welcome.
Thank you. Have a great night.
You too, Julie.
Trisha, mine's is still solidifying, but I did have one question. Is that too low for the comb? Is that
I can't see it very well. I think no,
okay?
no.
I
It
think I'm
just
gonna have to reheat mine because I didn't put mine in deep enough.
that's okay. do that tomorrow. Do
Yeah.
that tomorrow before school starts, and then it can solidify through first period.
I gotta go boo my science coworkers.
Yeah.
I'm booing
So,
'em.
and that's what I did. Here's mine. Here's my trash gel I made. I'm gonna reheat it tomorrow. No worries.
Oh yeah. Them holes ain't very.
That's okay. That's okay. That's why we do this now.
So do I don't refrigerate it, right? I just leave it.
You can I would just close it. And then tomorrow you can chunk it up and reheat it and re-pour it.
So I store it in the fridge after that. Like
Yeah.
I take this out, pour water. Once I get one that I like, I might have to cut this a little more.
Yeah.
I'll do that. I'll figure it out.
Yeah.
I'm
Once
hoping
you
it's not enough because mine's pretty much solid. I'll do that tomorrow.
okay. Have a
All
good
right.
night, Haley.
Thank you. Bye,
You're welcome.
everybody. It was good seeing y'all.
Bye. Have a good evening.
You too.
Mine's finally solidified. See y'all later.
Nice.
Okay. Bye,
Thank you.
Shamika.
Thank you, Miss Tricia.
You're welcome. Have a good
Have a
night.
good, you too.